Hi everyone, my name is Parth and I'm back with another video. So this video will talk about the concept of generics in C Sharp. So let's get started. So the agenda of this video tutorial would be we would be getting familiarized about generics. Then we'll see how we can apply generic to a class, to an interface, to a structure, how we can define generic methods, and finally, how we create generic delegates. So what are generics? Generics are nothing but they are a concept of type parameters. So by type parameters means we are deciding the data type of the maybe a class or a structure at runtime. At runtime means when it is being utilized. So generics make it possible to design classes and methods that delay or you can say defer the specification of one or more types until that particular class or method is declared and instantiated when we create the object of their class. The .NET Framework class library contains several, you can say numerous generic collection classes, and they all reside in system.collections.generic namespace. Generics basically allow us to have type safe code, okay, without compromising the type safety, performance, or productivity. So the advantage of using generics is it basically maximizes the code reusability, it provides type safety, it increases the performance, and it also helps in code blot. So basically, code reusability means we can reuse the same generic class we have created again and again. Type safety means that it takes care of the data type at runtime. Performance, it obviously increases because we are writing less code, so it will take less time to execute. And let's also look at some generic features. So there are 3 to 4 generic features which we use in C Sharp. So first is the default values. So in generics, it is not possible to assign null to a generic class to a generic type. Okay, so you always use the default keyword to initialize a default value to a generic type. It can be either zero or null. Second is constraints. So if generic class need to invoke some methods from the generic type, you must add constraints. Next is the inheritance. So a generic type can implement a generic interface only. So when you are deriving from a generic base class, or you can say a generic parent class, you must always provide a type argument instead of a base class generic type parameter. And the last is static members. So the static members which are present inside, let's say, a generic class are only shared with one instantiation of the class. So like we say that static members in normal class do not require object creation. But if they are static members of generic class, then they are shared only with the one instantiation of that generic class. Next comes generic class. So generic classes basically encapsulate operations that are not specific to a particular data type. So we can create a class which is generic and which can be used across multiple data types. So we are not adding a class specific to one data type. The most common use for generic classes is with collections. So we have different collections in C Sharp like linked list, hash table, stacks, queues, trees, so on. So the most common use of generic classes is with these types of collections. Operations, let's say some mathematical operations such as adding or trying to add some new items or removing the items from the collection are performed using the help of generic classes, because generic classes do not consider data type. It performs in the same way regardless of the data type being stored. So here we see a syntax how we create a generic class. We use access modifier, which is public. Then we use class keyword and we use the class name. And after the class name, you can see in the angle brackets, we are giving T. So here in the angle brackets, T means a generic type. So we are not defining what is the data type for the parameters inside the class. And then inside the class, you write the class members or whatever methods you have, you write your code inside that. Also, when we are declaring a generic class, we have uh, basically you can say a feature where we can basically apply some restrictions to the kind of data types that are client code which is inheriting this or which is using this generic class which we create. So we can apply some restrictions on what data type it can use. So like you can see, we have an example here. We have a class employee list, which is a generic class. And see, we have written here where T, which T means the generic data type can be of type employee or I employee. So employee must be a class here, and an I employee can be a interface. So whenever a client tries to inherit or use this employee list class, he can only give the data type of this class as employee, the parameters, or the I employee interface. And since we're talking about constraints, so in case of a generic class, we can apply constraints to multiple parameters, or we can apply multiple constraints to a single parameter as well. Followed by class, we have interfaces. So we know that interfaces are used because C# does not support multiple inheritance. So same concept is here for generic interfaces. So basically, we create generic interfaces for generic classes or for the generic classes that represent some items in the collection. We use generic interfaces to avoid boxing and unboxing operations on the value types. Dotted Framework class library defines several generic interfaces which we can use in our classes, and they all reside in system.collections.generic namespace. For generic interfaces, we have two types which we can use, which is covariance and contravariance. So covariant and contravariant generic type parameters, they provide basically greater flexibility in assigning and using the generic types. For example, covariant, covariant type parameters enable you to make assignments that look much like ordinary polymorphism. So when we are using generics, we can use the concept of covariance and contravariance, which behaves much like the same polymorphism which we see in normal classes. So now we have covariance with generic interface. So a generic interface is covariant if the type is annotated with the out keyword, and a generic interface is contravariant if the type is annotated with the in keyword. Next is generic structures. So similar to classes, structures can be generic as well. They are similar to generic classes. They perform everything which a generic class does except the inheritance features. So you cannot do the inheritance in case of generic structures. So here is an example. We give access modifier, which is public. Then we give the struct keyword. Then here we give the name, like we have a nullable of T. So T means the again the generic type. And then you're writing the code of a structure inside the curly braces. Next is generic methods. So we can define generic method also inside a class. So here's an example, like we have a swap method, and you see that it's a generic method, and we have two parameters. There are again the data type is not there. So will be taking that data type from the, you can say it's a reference type, because we are using ref and we are giving T, so its data type will be inferred and this method will be called. And then it's doing nothing but it's just swapping the two values. So we can define method specific generic type parameters even in the containing class does not use generics at all. So even if the class which has this generic method need not be generic as well, but a method inside a normal class can be generic. There's no issue in that. We can have constraints also on the methods like we have in the class. So when a method defines its own generic type parameters, it can also define constraints. Like we have a method here, sub method, its data type is generic. So we are giving here that the parameter for this can be only I comparable. So I comparable is a, you can say, an interface which is used to compare some values, which is inbuilt interface in .NET framework. One important thing to note here is that you cannot provide method level constraints for class level generic type parameters, because method level constraints are for method scope only. So all constraints for class type generic type parameters must be defined at the class level or class scope. The last topic is generic delegates. So a generic delegate basically can take the advantage of generic data types. For example, we are defining a delegate named del. Okay, it's taking one parameter of generic data type. Then we say that we have a method here, notify, and then we are basically passing the reference of that method, and then we are calling that method using our delegate instance. We have a concept of generic methods specialization, so which says that generic methods can be overloaded to define specializations for specific types only. And this is true for methods with generic parameters as well. Thank you. I hope you have gathered some information about generics in C Sharp. So I will see you in some other video very soon. Thank you.